Good morning. Today we'll be continuing with the exercise 5.1. So let's start with question number 17. It says that we have to find the relationship between a and b when the function is defined in this manner and is given to be continuous at x equal to 3. So given that at x equal to 3 the function is continuous, so we have left hand limit equal to right hand limit and is also equal to the value of the function at 3. So we check for these three things and then do the needful. So let's first find the value of the function at x equal to 3. From here you will be using this. So substituting for x as 3, we get 3 into a plus 1. Let's call it equation number 1. Now left hand limit at x equal to 3. So what we have is limit x tending to 3 minus fx is equal to limit x tending to 3. You drop this negative sign, replace the definition of the function on the left, which is ax plus 1, which gives you 3a plus 1. And the right hand limit at x equal to 3, limit x tending to 3 plus fx is equal to limit x tending to 3. You drop the positive sign, replace fx with definition on the right, which says bx plus 3. Substituting, we get 3b plus 3. Now as function is continuous at x equal to 3, left hand limit is equal to right hand limit is equal to the value of the function, but we already know that these two are equal. So first of all, let's simply find left hand limit equal to right hand limit. This itself will give us the relation between a and b, and this gives us 3a plus 1 is equal to 3b plus 3, which gives us 3 times a minus b is equal to 2, which gives us a minus b equal to 2 by 3, or you could write it as a equal to 2 by 3 plus b. This is the required answer. On the same lines, we can do question number 18, another very important question. So we have to find the value of lambda for which the function fx equal to lambda times x square minus 2x if x is less than or equal to 0, and it is equal to 4x plus 1 if x is greater than 0, is continuous at x equal to 0. Okay, so here again the same way, we'll first find the value of the function at x equal to 0. So we'll consider this result, and for this we'll get lambda times 0 minus 0, which is 0. So this is equation number 1. Now let's check at x equal to 0. We have to find the left hand limit, which gives us limit x tending to 0 minus fx is equal to limit x tending to 0. You drop this minus sign, replace fx with definition on the left, which is x square minus 2x. Substituting, we get it is 0. Right hand limit, limit x tending to 0 plus fx, limit x tending to 0. You drop this positive sign, replace fx with definition on the right, which is 4x plus 1. This gives you 0 plus 1, which is 1. Now we see that from 2 and 3, we see that left hand limit is 0 whereas right hand limit is 1, and which can never be equal to each other, and so it implies that left hand limit is not equal to right hand limit. It implies that limit x tending to 0 fx does not exist, and which implies that function f is not continuous at x equal to 0 no matter what value x takes, because neither the left hand limit nor the right hand limit depends upon x, no matter what value lambda takes, because none of them they depend upon lambda. Okay, so irrespective of the value lambda takes, this function is discontinuous at x equal to 0. Now to check continuity at x equal to 1, again we find the value of the function at 1, and at 1 we have 1 is on the right. So let's first write the function fx is equal to lambda times x square minus 2x. When x is less than or equal to 0, it is equal to 4x plus 1 when x is greater than 0. So now here we can see that 1 lies on the right of 0. So we will take this value for x equal to 1. So what will we get? 4 into 1 plus 1, which is 5. Now we can see clearly that on either side of x equal to 1, whether we are finding the left hand limit or the right hand limit, fx is at x equal to 1, fx has only a single definition, which is 4x plus 1, which is always continuous, it being a polynomial. Okay, and the limit also always exists and is equal to the value of the function. Okay, so it implies that here at x equal to 1, f is always continuous irrespective of the value taken up by lambda. So what do we conclude? That at x equal to 0 it's never continuous, whereas at x equal to 1 it's always continuous.